each other. For example, one X atom in a molecule, and that X atom contains the unpaired spin. And the same X atom, if it has its own nuclear spin, effective nuclear spin greater than 0, then they could interact with each other, and as a result you can have the splitting, and that is called the hyperplane splitting. And super hyperplane splitting, where nuclear spin and electron spin, they are associated with the two different atoms, not the same atoms. Now you may have a situation where you can have only hyperplane, no hyperplane splitting. That is one case. There your only MS containing transitions, you would be seeing it, and that transitions could be splitted further based on the molecular geometry, the distortion, coordination impact, and all sort of things would be there. On the other hand, if you have the nuclear spin attached to the same atom carrying your unpaired spin, then you would be having hyperplane splitting. On top of that, if you have the associated atoms, that means the atoms connected to the original X atoms, if they are also linked to have the same nuclear spin or similar or nuclear spin active situation, so that would further interact, and that makes the process much more complicated, and you will have further splitting, which is called super hyperplane splitting. So you can have no splitting, you can have hyperplane splitting, additional super hyperplane splitting, or you can have only hyperplane splitting, not the only hyperplane splitting, or only super hyperplane splitting. So all sort of options are there. So you need to understand how the option could grow over there and how to interpret the situation. Now remember that in EPR, in certain cases it's rather difficult to follow it. Why it is difficult to follow it, I will explain all these things in a sequential fashion. Because once you have large number of splittings, then manually you cannot figure it out by using the simple energy diagram and all sort of things, which goes beyond of one's immediate control. So what people do normally, the people go for the simulation. All programs are available, but simulation is not that blindly you can do the simulation. So there are several parameters you have to inject into the computational item, and that requires a lot of expertise. Okay, so if you have a simulated pattern, and if that matches with the experimentally observed EPS spectrum of any particular compound, then you could argue that the simulation is appropriate, and then you have to go back to the parameters what you have and had injected into the simulation pattern, and based on that you can correlate the electronic structural feature. Okay, all you will learn slowly and see how the situation goes on. For example, let us look at this way, that you have one atom which contains your spin s equal to half. So naturally ms equal to plus minus half, and we know that ms plus minus half, how it could be splitted. There are certain problems over here. Okay, but the fact is that, so we know already that energy of an electron in a magnetic field situation, that is your equation minus mu bar h, and that is g beta ms h, right? And if I consider this for ms situation, then it would be negative, then whole term would be positive. So minus half would be the lower energy, plus half would be the higher energy. Already we have talked about. And the energy we can write in the form of minus half g beta h plus half g beta h, and the difference, that is h nu equal to your h nu equal to just g beta h. Okay. Now let us assume that this atom carrying the unpaired electron, which is having another atom which is linked to this original atom, also having the nucleus. Here we are considering the super hyperfine situation, not the hyperfine situation, right? Hyperfine situation means the same atom should have the nucleus spin. So what we are assuming at this point, that this atom does not have any nucleus spin, but it is having the attached another atom, okay, which contains the nucleus spin, say I equal to 1. Very hypothetically you are considering. Then if I equal to 1, I equal to 1 means mi equal to plus minus 1. That means 1, 0, minus 1. Then each of the electronic state, now because of this interactions between the ms and mi, each of the electronic state would now be split into 3. So ground state would be 3, 1, 0, minus 1, and excited state would be minus 1, 0, 1. Okay, and you must remember that the energy pattern would be different. Here minus would be the lower state, here plus would be the lower state, here plus, excited state case minus 1. And then you can expect to have the transitions not between this level. This level means it would give you one line only. Okay, but instrument, instrument cannot differentiate that out of 3 lines, which one is the original one line. Okay, instrument would give you essentially the final result. So final result is essentially coming out of the interactions between ms and mi. Remember this thing, and that is how you will be getting 3 lines by following certain selection rule. The selection rule for ms level is plus minus 1. That is how you could see it here. And selection rule for mi equal to 0. So delta mi would be 0. That means from 1 to 1, 0 to 0, minus 1 to minus 1. So one line is being splitted into 3 lines. One line if you simply consider the electronics field, and that has now been splitted into 3 lines because of the ms and mi interactions. Okay, that is called super hyperfine, what we have considered over here. Now, if we need to bring hyperfine and super hyperfine interaction into the picture, you have to have some pre-knowledge that what kind of nuclei would have the effective nucleus spin, right? So it is, you'll be getting it in any literature, internet, everywhere, that there are actually 3 kinds of nuclei. One, it's called the even number of protons and neutrons. That means mass would be even, and even number of proton and neutrons, say carbon 12, helium 2, 2, oxygen 8, 8, they're I equal to 0. That means if you have any molecule, say carbon containing molecule, where one unpaired electron is attached to the carbon center or helium or oxygen center, and then you can only have the ESR spectrum due to the ms state, because mi equal to 0 over here. No hyperfine interaction should be there, or super hyperfine interaction for having this kind of nucleus center. On the other hand, if you go for even mass but odd protons or neutron, okay, that means 2H, nitrogen 14, the available nitrogen setup, boron 10, there you will have the integral spin 1 and 3. And you have another kind of nuclei where you can have odd mass and odd or even proton neutron. Okay, then you have the